I am so honored to be moderating this panel. These are powerhouse ladies, and I'm loving the diversity in the room. Just a quick 2-second bio about me. I am Christine Galion, as Sean had mentioned, and I work for Sony in the Sony cybersecurity organization. So I come from the tech world. You will learn that the panel also comes from the tech world, but also from like the variety of R&D, biotechnology, healthcare sciences. So very excited about that. And I know we're limited in our time frame, and we have all these powerhouses. So I'll go ahead and just get started here. Um, I'd like to start, first of all, by thanking all of you for your time today. And the first question is, if you can give a quick background on how you got started in tech and also in your industry, and then tell us, as a diverse woman, how you forged your way into where you are now. And let's start with you, Lizzie, and then perhaps we can do Andrea and Belinda.
Hi, thank you, Christine. I am happy to be here with this amazing company. And I am Lizzie John. Right now, I am a professor at the University of Texas at Austin in the Electrical and Computer Engineering Department. I have been here for more than 2 decades. I grew up in India. I did my engineering in India, and to explain a little bit to the way Christine asked the question, how did I get to engineering? I would say with some encouragement and appreciation or from some of my teachers as starting as young as first grade. So a first grade teacher pointing out that, oh, you are doing good in math. And I'm mentioning it only to maybe some of you are teachers. Be sure to identify talent when you see it in the children in the class, children in the neighborhood, children wherever, people, when you come across somebody, maybe a little word that you say might go a long way. And so I went to engineering in India. I did my undergraduate degree. I worked for a couple of years in the Indian Space Research Organization, which is like the NASA in the USA. And I came to graduate school and I did a master's in the University of Texas at El Paso, a small school, but that's where I had a full scholarship to do my master's without my own money. That made my entry to the United States. And then I did a PhD at Penn State and in computer engineering, and I have been professor here for lots of years. And I enjoy my job.
Great, thank you very much. And you didn't even mention, you are so humble, but you didn't even mention that you have 15 patents as well.
That is correct. Maybe if I say a little bit more, I would say inventing. I grew up with Mary Curie's story as a young girl. In my high school, her biography was something we had to read. Madame Curie or Mary Curie. And so at that time, my dream was to invent an element. I wanted to really find a place in the periodic table. And that was, as a middle school kid, that's what I wanted to do. I had a periodic table handmade. I drew it and put it on my wall and I look at it, where is my element going to be? So inventing was something I wanted to do. And then during my master's, I attended a seminar at the University of Texas at El Paso, which was about what is a United States patent, how do you do it, and things like that. And I thought, this is something I want to do one day. And during my job, I had the privilege of working on some interesting projects. And I have 15 patents and 7 or so pending. And some of them are also in international countries. in addition to the 15 US patents. So I'm very proud, and you can see, I think, 4 of them right there. And so I'm very happy and proud that I was able to contribute some innovative things to the field of science and have some patents.
Yeah, thank you for that. Thank you. And then next, I guess, Andrea, same question. Let me know if I need to repeat it. But I'm also going to preface that you too have patents as well. So same question to you.
So thank you and welcome everybody to the virtual audience. So I guess similar, my interest in engineering kind of also goes back to my childhood, but also my family. So my grandfather was an auto mechanic. So I was very fortunate. You know, he always encouraged me to take things apart, put things back together, even if I didn't necessarily put them back together the right way. At least he could fix my mistakes. But then I realized as I got older that I didn't just want to, put things back together that other people had invented. I really wanted to, design my own things. However, when I was in high school, I was really only exposed to chemistry, biology, and physics. And so the closest thing to designing cars was really physics. So I went to college, majored in physics. I was surrounded by a lot of, really talented physicists, but I realized that, my dream wasn't necessarily just to discover new things, although I have to admit having my name on the periodic table would be amazing. You thought way bigger than I did. I really wanted to build the instruments that would enable other people to discover, kind of more working behind the scenes. And this was really the path of an engineer. So that's really what inspired me to get into engineering. And that's really what I do now. So I lead a large research team. And our goal, from a big picture perspective, is to solve other people's problems. So researchers come to us and say, we really like to be able to measure this, small protein, or we would really like to be able to, signal with our satellites better. And so we try to develop instruments that will enable their work. So that's kind of the big picture motivation. And in my research team, I'm a professor of chemical engineering at the University of Southern California. But even though I'm a professor of chemical engineering, the group comes from all of the different engineering. So material science, chemie, electrical engineering, biomedical engineering. And this is very common for engineering today, to not just focus on a single field, but to really bring engineering and science together to solve larger problems. And patenting is kind of an end result. It really just happens. You invent things, you discover things, and and then patents come. Especially if you're solving important problems, like the other amazing inventors on this panel today. So thank you.
So same question to you, Belinda. How you got into this industry, and then also from the perspective of a minority woman, and also how you forged your way.
Yes, thank you. It's an honor to be amongst this privileged panelist. And I am the first in my family to go to college. My passion was to follow medical studies. Because of my personal experience with my siblings, they both had complications during birth and neonatal respiratory distress syndrome. But I fell in love with research. I started doing research at a small undergraduate college in the University of Puerto Rico, but on the east coast of the island. And I kind of stayed away from medicine because I really fell in love with doing research. And I found my passion to be working with proteins and spectroscopy in general. And that was my secret of success. So I went to Rutgers University, where I did my PhD in physical biochemistry. And I was able to isolate proteins that are found in your lung that allow you to breathe. And so for one of the few occasions in science, my research, basic research, using spectroscopy isolating proteins from animals, had a clinical impact to patient outcome. And I then had the privilege to work with Frank Prendergast at Mayo Clinic. And there I continued to expand into more interdisciplinary research. So it was always having two different mentors, one a biologist, another one a clinician, or a physicist and a biologist, or a chemist and a biologist. And I was the one in the middle, being able to translate and have common communication with the two fields. So I was inspired to be able to have an interdisciplinary group. I wanted to return to Puerto Rico, provide Puerto Rico its investment on me, give it back, give it to the new generation of students. And so I'm a tenured faculty member at the University of Puerto Rico Mayagüez campus, which is well known for engineering. I have an interdisciplinary group, so from biologists, biotechnologists, engineers, and chemists. And we all come together to speak one language, which we all learn from each other, and solve the problem of understanding complex molecules like proteins that are the workhorse in your bodies and also in the cells. And they're very complex, and you have to use different tools. During that time, we always found a moment in a research project where there was something going on with a protein. It aggregated. And we found that we had a unique solution and we really understood the problem. So that's what led to a patent filing. And we became pathfinders. We were the first to license patents from the University of Puerto Rico. And I wanted to really be able to spearhead this type of research and try to provide new tools worldwide that would impact clinical outcome as well. So the spin out, and I am today an entrepreneur as well. Protein Dynamic Solutions, I'm the founder of that company. I'm today the CSO, CTO, joined with a small but very experienced group that we've learned from each other. And the journey continues.
Yeah, thanks, Belinda. And actually, that's great that you mentioned that, because as a follow-up question for you, I know that like from you, you come from like an entrepreneurship perspective, right? So
Yes.
you've been doing a lot of R&D work. I'm looking at my notes right now, and you have to sell your work and findings to investors. So could you tell us more on your experience with that, and maybe tips to the audience, on ways on how to advance in this field from your perspective, and also from an R&D perspective, trying to get the investors from an entrepreneurship perspective?
Right. So that's an excellent question. The R&D support, I would say, always go towards grantsmanship. Have that be your secret of success, because it will be evaluated by a third party, free of conflict. You want that. That will always be seen in a very good light by investors. So private investors, venture capitalists, angel funders are always looking for a great idea, passionate person. It could be an engineer or scientist, but you have to have that idea that will bring economic success to the company. So it's really understanding the problem, bringing a real solution, and being able to provide innovation in a transformative way. So we've designed this microscope. I've had hundreds of presentations, either in conferences, as well as pitching, which is a very short presentation that really provides the overall outlook in terms of your invention, the problem, the solution, and the economic aspects or financials associated with with your company and your team. And you have to bring a very convincing case through a story. So that is important. And never give up. Women will have a smaller level of funding through private investment, but we can do a lot more with it. Okay, we are that way. We can manage funding in a very successful manner, and the outcome will speak for itself. So we've had active collaborations with the FDA and NIST. We've had great opportunities of interacting with VC-backed companies as well as global companies. And it's all in the area of biotech, all in the area of really trying to understand these therapeutic proteins and providing them to be efficacious and safe for patients worldwide.
Yeah, great.
And
Thanks.
today we have multiple patents. It just continues.
It just continues. I mean, how many patents? Just the three of you. Oh my gosh, all together. How many patents do you all have? The next question I have is Andrea. So you come from such like an incredible path, professor of chemical engineering, developing and innovating devices for precision medicine, which, you know, like I said, I'm in tech, I'm in cyber, but I love like the AI of precision medicine. And you're passionate about advancing biomedical research. What I would like to ask is that, you know, in this, especially after COVID, in this environment right now, it's pretty inundated. It's like, oh my gosh, there's COVID. And so now so many people are trying to enter the market. So how do you make yourself stand out? How do you make your message unique enough so that investors or the public or policymakers can really take you seriously?
So I actually think this follows beautifully on what was just mentioned about pitching and about grantsmanship. So it is critical to not be overly technical in your pitch. If you launch in with your pitch about how your new device is going to be able to detect the point methylation on the 16th base pair of a DNA using a quantum Sears diagnostic, you've lost people at the point methylation part. It doesn't matter how amazing your technology is, nobody's going to understand what you're saying. And if they don't understand it, it doesn't matter. You have to start off big picture, right? Like, what is the problem you're trying to solve? Why are you the best person to solve it? Why is your problem even an important one, right? You can make an amazing technology, but if it's not solving an important problem, it's great for an academic setting, but it's not really a product, right? And you can even have an amazing, in my field, you can have an amazing device, but if you pick the wrong market, it's not going to be a good technology. So your pitch needs to incorporate not only the thing, your device, but also the market and why it's an important market. So you need to consider all of these things from an investor's perspective, because you aren't pitching to other scientists, you're pitching to investors. And investors have a very different set of questions that they're benchmarking your pitch against. They aren't necessarily interested in if it's like the best science. They're interested in, is it the best solution for the problem? And you can have something that's, amazing science, but it's not a good product. You can also have something that's like not super state-of-the-art science, but it's an amazing product. Like you can take that COVID-19 antigen test, right? It was at its heart, it was just a slight variation of a pregnancy test, right? But it was an amazing product, amazing, right? But it wasn't necessarily a huge, like, massive advance in terms of diagnostics, but solved a huge problem. They also got it through FDA clearance. record speed. So I'm not trying to minimize that. That was insane. So you really need to think about your market and your pitch. I just want to be clear, super impressed at that FDA speed. That was just a miracle. Crazy. So really it's a, pitch, market, make sure you really simplify what you're trying to convince people. That's where a lot of people go wrong.
Yeah, I feel like everything needs to be seamless, so to speak. So it's not like you're trying to, you have to really pick your audience, I guess.
Yes.
Yeah. And then Lizzie, you come more from like the invention and innovation perspective. And there are not that many women in your shoes. I already had this on here, but then you mentioned it because I love that story of the nun that that really encouraged you. But can you tell us maybe ways that we can connect more with women and get them interested in your field? Any opportunities? How can we advance opportunities for women in your field?
Okay, so just as we mentioned before, I love inventing, and so women will have a lot of opportunities in this field. Oftentimes, some discouragement somewhere along the way is what prevents many from reaching here. So the Belinda's advice, never give up, applies from day one. So you may have a discouraging situation, an embarrassing situation, many of those when you grow up on the way, and never give up. And so I would actually say you are not the only one that are facing embarrassing situation and discouraging situation. I was actually, just to get a little inspired, I was reading the biography of Professor John Goodenough, who is turning 101 years old this July. He is a professor in our university, and he won the Nobel Prize 3 years ago. He won it when he was 97 for chemistry. And you read his book, and you will see he describing how he almost failed his PhD candidacy exam. He did so poorly in the third exam that he thought, I'm not going to pass. I'm not even going to write the fourth one. And he went and played a softball game. And after the game, he was relaxed. He thought, oh, anyway, I'm failing. What if I just go and write anyway? And he went and wrote and he passed. So these types of things happen in everyone's life. And he mentions one more story, and that is when he was looking for a job and his advisor took him to give the speech in Washington, D.C. And when he gave the speech, an old man from the audience stood up and said, but young man, you don't have the Brew-1 distance right in what you presented. And he realized the person who asked the question is scientist Brew-1 himself. And he didn't know what to do. And the silence that followed that question really demolished him. And the chairman, the department head at University of Chicago, where he is doing his PhD, is in the audience watching this miserable situation. He said, I went to the hotel, demolished. His PhD defense is going to be next week. And he said, it's going to be lost because the head of the department saw this miserable performance. But within a week, he was able to come up with an explanation. And when he went to the defense, there were more questions, but he actually answered them or confronted the question he wasn't quiet like he was in the previous case when he was not expecting this question. So what I would tell anyone is when you have these embarrassing situations, when you feel like it's all lost, don't give up, think more. There is nothing to actually learn if you just keep winning. There is so much to learn if you are losing. From every failure, you can learn something. So from every disappointment, from every failure, try to learn something. Don't give up. Think more and keep staying in the field. So that's the way, you have to be there. If you go away from the field, you cannot be in the field. Show up in places where you can be, show up in places and learn more. Read a lot, learn a lot, don't give up. Those are things basically what I would say. And I would also say a little bit more about inventing. Jack Kilby, another Nobel Prize winner who did the semiconductor chips, the first IC or the integration. So he has a quote, which is on the wall when I walk up to my office every day. It says, if you work on interesting projects, invention is kind of a natural consequence. So, and you women, you work on interesting problems every day. Whether be at work, on the way to work, there are so many problems that you face. Every problem is an opportunity. Every problem you see, look at it as an opportunity to invent something and solve that problem. As a simple thing, I can say, you just drive your child to a sports practice. There is no parking, you were a little late. You are parked behind, you had to double park. You are like, someone in front, they may want to go, what is going to happen? And maybe you should invent a thing that, and I don't want to write my phone number and put it there for this person to have forever. I want that one-time call thing where I can give a number, which is a one-time thing. It exists now, but 20 years ago, when I was in that situation, I'm like, I want to invent a thing. I want to invent a thing to put there. They can call me one time, but they will not have my number. They won't call me. Every little problem you face every single day has a solution or may have a solution. You should look for it. Keep inventing things, from daily life things to stuff in work. For me at work, I am in the computer engineering field. I'm a hardware designer. I am trying to make computer hardware better for whatever software it's running. Who is competing against me? I'm in the academic world. I have a few students who work with me. Competing with me is Intel and AMD and Google and NVIDIA and all of these huge companies up there. So when my students try to write papers, these companies are writing papers too. It is extremely difficult to come up with ideas and prove it before they would do it. We may get the idea faster, but by the time we do the experiments, we are slower because they have more resources, more manpower, more ability to do it fast. So I tell my students, we need to be fast. It's not enough to get the idea. We somehow have to make it, to come to some sort of prototyping, to be able to prove it, have enough experiments to show, see whether it's a good idea or not. So in any invention, that's extremely important. You have to do it very fast. And it all relies on finding that problem you want to solve. And the problem, most of the time, the problem, once you understand the problem really well, it's easy to solve. Often you are just kind of a little bit away from the problem. Staying on the periphery, you cannot invent anything. You have to go deep. You have to go deep into finding that problem. So for instance, what we do is, things are running on this computer. It is slow. How could it run faster? Both the hardware and the software are so complicated, it's not easy for you to just find out, oh, if you just do this one change and add this piece, it'll be faster. That's not easy for humans to do anymore. Hardware and software are extremely complicated. So we have workload characterization methodologies to find, this is the part that's actually running really slow. How can we improve that? We have to come up with a hardware mechanism to be added into that chip or into that architecture in order to speed it up. And we have to prove it. And in my academic setting, I have to prove the Office of Technology commercialization that I have an invention here. This is a real problem out in the world, and we have an invention. This is some things we have written down about it, and then it goes to patenting from there. So constant perseverance, never giving up, identifying problems, go into the detail, passionately dig deep in to really know the problem, come up with solutions, and all very quickly, because others are working on the same problem.
Yeah, thank you for that, Lizzie. And, I totally understand where you say you have to go deep because that's where a lot of the thought processes comes from. Just switching gears a little bit more. Again, like I said, I'm from the tech world, right? And it is still March. It is still Women's History Month. And some of the themes that we've heard, for Women's History Month last year, I believe it was break the bias. This year, it's embracing equity. And then, when we all initially met, we talked also about unconscious bias. And then, of course, from my tech field, cyber field, I started talking about AI. There has been or have been some evidence about, from the HR world saying that, sometimes job descriptions are usually tailored for men. That's actually, studies have shown that. Workspaces, even uniforms, right, have been tailored for men. Now, with the rise of Chat GPT, and just to let you know, all my questions were mine, not from Chat GPT. But with the rise of Chat GPT and AI, artificial intelligence, there is a percentage and some conversations saying that some of those, the AIs have bias in them as well. And so it's really important for all of us as women to be part of that conversation, to be part of that room, to be part of molding this, have a seat at the table and shaping the future, especially in AI. And I'll start with you, Andrea, because I know that that's actually part of, some of what you do. Thoughts on the AI space, especially in healthcare? How can we address this unconscious bias per se?
So actually, I will. I read a really interesting article. I'm going to take a really fast break. I read a really interesting article about creating new images based on AI, and it actually was looking at the American smile. I don't know if anybody else saw this article, and about how a lot of the images that are being created, the AI images, are based on using the American smile, which is like, a really teethy smile. But culturally, everywhere else in the world, most people don't have this super, showing all of your teeth smile. So now all of these AI-based images are being influenced or biased by the fact that a lot of the AI is being developed in the US. And so images are, like artificial created images of, World War II documentaries or Indians, like in India, are being shown with these huge, just glowing smiles, which is not culturally appropriate for what all these different ethnicities, how they would actually behave. And so that is an example of like ethnic bias, but then you also have healthcare bias. And healthcare bias is really getting to, from my personal perspective, a lot of women's health issues. When they do a lot of drug trials, they'll start with a population that can often be male-centric, and even worse, it can be, age 20 to 35, healthy male-centric, which frequently does not represent either the female population or even just the general population at large. And then depending on where that population happens to be, kind of centered, it can miss large features that may be present in other ethnicities. And if that kind of forms your foundation of your AI, then it can be shifted one way or the other. It can be shifted in terms of weight. We also, as a group, discussed this. It can be shifted in terms of weight, height, obesity. Like my husband is very fit. He also is Turkish, and his body profile is very different from kind of the standard body profile of an American. So he's routinely told that he's overweight. Ironically, he also has 10% body fat. So like those two data points like don't match up at all. So like just relying on AI in healthcare doesn't work without a sufficient data set. One of my computer science collaborators has one of my favorite sayings, which is garbage in will give you garbage out. And right now we seem to have, we're relying on AIs that have maybe not garbage going in, but perhaps incomplete data sets going in. And if you have an incomplete data set going in, then the data set that's going out that we're using to make decisions could also be incomplete. But this falls back to the unknown unknowns. We don't necessarily know what we're missing in our data set going in, which means we don't know what information we're missing in our data set that's coming out of the AI, which to me is a really big concern and kind of leaves this very unsettling kind of question in the pit of my stomach. That was a very long answer to your question.
No, that's a great answer to the question because, you know, it's just within the last month that, you know, Chat GPT started coming about and the media and everything. And I think it's a conversation that needs to be had. And especially with these biases, it needs to be addressed. And we as women need to be part of that conversation. And I see, Belinda, you are nodding your head so much. So anything?
Yeah. there are 3 points. I agree with Andrea and all of you. The bias can be at the beginning. It can be due to limited data. Epidemiologists are supposed to be able to make sure anything that has to do with the population in the US, that you have a representative group. And I remembered in our discussion the other day, I mentioned COVID-19 and how there was an outcomes study on epidemiology, but it was all based on male patients when that should have not been the case, especially for COVID. And it is up to us. We have to try to be in that table of negotiation of decision making before or during that time when the project is going to be conceived or conceptualized. Sorry, not conceived, conceptualized. And being able to put our point of view in federal agencies for funding. I think that is the way to be able to ensure that everyone is included, especially women. And if we look at human samples, for example, that are donors based, there is always going to be a larger cohort of male patients donating than females. And there has to be a way of being able to modify that by incentivizing women in different ways, helping to take care of the kids so that they can go and donate a blood sample, for example. These are things that we all know can make the difference, and we just have to implement it as a policy. In my case, I also wanted to add regarding AI, the quality of the data is important. You have to have accurate, reproducible data that is of high signal to noise, you know, to be able to have an outcome due to machine learning algorithms that will be valid. And I think that has always been an issue for science in general, either based on biological results or any scientific result. It's always going to be something that's in question. And I think we can improve on that very much so. And I agree with all of you that we have to persist. And the basis of being able to be successful is to be in that table negotiating. Don't be intimidated. We have a seat. We have a right to be in that seat.
Yeah, absolutely. And it leads me to my next question, actually. And perhaps, Lizzie, we can start with you. I'd like to talk about the importance of mentorship and networking, because Belinda, you mentioned it. It's like, we need to be part of it. We need to be in that table. But sometimes it's like we feel alone. We don't know where to start, but that's really where networking and also mentorship comes into place. So, and as they always say, you know, it takes a village. So, you know, and I truly believe that 80% of your success is just showing up, show up, but how do we know, what the events are? So I don't know, Lizzie, do you have anything regarding mentorship? You said you had, some of your colleagues and peers in the university, but I know one story. I had gone to an event just this past weekend where they were saying that, look, a few years ago, I was trying to find women's network groups, but they were always, really early in the morning or at night. And it, they could not attend it because, in the morning they're preparing the lunch for, the kids, and at night they're picking them up from school. So I'd like your thoughts on how we can really embrace mentorship and also networking from your perspective.
Networking is extremely important, and you need mentors, and it's not only women. Men all have mentors too who are successful, so it's not a women thing. We need mentors because we all need a sounding board for new ideas. We all need some constructive criticism on something, or there is something you want to ask somebody, should I do this way, or what are my options there, and these are my thoughts, but what do you think? We want someone to sound it out and get some opinion and then decide our path. How do we find them? It is true, it is very hard. You have to, if you are in school, it is just fine. Teachers, you can approach teachers and you can tell something and say, I'm kind of thinking about these kinds of things and I have no idea who could give me a little bit of advice on this. Either they would do or they would take you to someone. You could say to, your parents could maybe take you to some neighbors, someone in the community who could give you advice when you are small. It may be teachers, coaches, people in the community, somebody. But as you grow older and you are already working, you probably have to see whether anyone at work is approachable. You could try that. I am actually lucky at this point in the university. There are so many events that happen and show up. Sometimes you feel, oh, I don't have the time, I have this to do. But you should have. Every week, I will attend one event, or I will try to find a new connection this week. So have something with which you work, try to find new people. This Monday, there was something happening in the Dell Medical School at the University of Texas at Austin. And it was like 20 companies from the United Kingdom coming, and they were trying to develop collaborations. I thought, oh, I'll go. I just want to see what's up there. So I registered, I went there. One encouraging thing, that's the main reason I'm mentioning it there, about 40% of those who made the pitches were women. I was extremely pleased. And I went thinking I want to talk to one company, which I did, but another company came and talked to me. They found me and they said, you said you are working on machine learning. We have this thing and we want to talk. Just show up in places. Many will be useless and you may benefit nothing, or you feel nothing happened. You wasted time, you struggle for parking to be there, all that stuff. But you never know when the good connections come. Make connections. Try to find somebody new every week, or at every month. I should find a new connection to help me with my work and keep going up in my work, something like that. So make a conscious effort to do that. And depending on your situation and where the environment is, find what the channels are and talk about it to people you can trust and say, I'm looking for, somebody who has some expertise in these kinds of things, or say some things, and it might lead to some other conversations, which will lead to something useful.
Yeah, thank you for that. And I know we only have a few minutes left. So one of the things I had written in here is that, like I said, this past weekend, I went to a women's leadership, and it's been so nice, like throughout the entire week. It was like golfing weather, right? And then the day that that symposium was, it was Saturday. We had to be there at 7. It was 30 degrees. It was raining. It was dark. It was dreary. I did not want to get out of bed. However, like I said, success is like 80% of, just showing up. And I wrote in here, and it's like, you belong in the room. Sometimes some people are like, I don't know, should I go to this? I don't know if I have anything else to say. But I always say, you belong in the room. You belong at the table, and you belong in the conversation. And you know what? Like, maybe it's not for you, but it's for that one person who saw you and got inspired by you and thought that, if she could do it, I can as well. So definitely show up to whatever networking event it is, whether it's virtual or in person. And I'd like to end this with a question for all three of you. So if you can come up with a word or a phrase to describe what you think the landscape of the future is. We're talking about trying to change things the way that they are now. We're still trying to like break that glass ceiling, but one word or a phrase that you would use to describe what you think the landscape of the future is. So I'll start with you, Belinda. I just see you're in the screen right next to me.
Yes, thank you. So, Pathfinders. I want to see more women Pathfinders. They're the ones that will change the world.
That's a great one. Thank you. I wouldn't have thought of that, but thank you. And then the next one that's on my screen is Andrea.
So I'm going to go with open doors. So historically, I think about a lot of startups and inventors and funding kind of being limited to kind of the old boys network, which is a very closed door network and just kind of ecosystem. So I would really like in the future to think of, everybody being welcome, the doors to the club being wide open, and everybody feeling like they can enter.
Yeah, that's great. I love that one too. Man, you guys are really good. Okay. So now, Lizzie, your turn too.
I will say butterfly effect. And what it is it is something the weather modeling people are the ones to use this part of chaos theory. It's a theory that says a minute localized change in one part of a system may cause a huge effect at a different time at a different place in the system. As an example, they explain it this way: a butterfly flaps its wings. Almost nothing happens when, it's such a tiny creature flapped its wings, but it causes a disturbance which keeps growing, and 3 weeks later, somewhere there is a tornado. So it's difficult to believe a butterfly could cause a tornado, but the theory says it can. So I would like to say little actions we women do can cause a little butterfly flapping here now. 3 weeks or 3 months later, somewhere there can be a tornado. So small actions, small encouragement you give to a student, you give to a neighbor may have huge lasting events. And we women do a lot of butterfly effects and keep doing that.
Thank you so much. That was so beautiful. So just for the audience to know, it was Pathfinders, Open Doors, and Butterfly Effect. So all of you, the panel, those who attended, all of you are full of unlimited potential. And I'm just so honored to have moderated this panel. I'm really excited for the path ahead. And so please, let's all stick together, support each other, use our talents, and use it all for change. So for the audience, please connect with all of us. We will all be that butterfly, and then we will all create a tornado. So thank you. Back to you, Sean.